Hey friends, Vincent here. Welcome to Fearless in Rust, where we keep Rust clean and simple. Let's get into it. Today, we're starting a small series on hexagonal architecture, also called ports and adapters. The idea is simple. Put your business rules in the center and push all the frameworks, databases, and HTTP details to the edges. The core only knows about ports, interfaces, and doesn't care whether data comes from HTTP, a CLI, Postgre, or a JSON file. In hexagonal terms, we have three big zones. First, the domain, entities, value objects, invariants. Then, the application layer, use cases that orchestrate the domain through ports. And last part, the adapters at the edge. HTTP handlers, repositories, tracing, and so on. In this first episode, we stay right in the middle, the domain. We are going to look at the single domain type, telemetry, and see how to design it in a hexagonal array in Rust. So, let's look at the project layout. Inside the backend crate, I have a core module and under that a domain module. This is where the heart of the business language lives. For today, we focus on one file, telemetry. This file defines the core telemetry event that the whole RustPulse runtime is built around. All the other layers, use cases, handlers, repositories, will depend on this type. But this type itself doesn't depend on HTTP, Axum, files, or databases. That's the key hexagonal property. Let's have a look into this file. At the top, you'll see the imports. Chrono for timestamps, UID for stable identifiers, and cert so you can serialize this type in a controlled way at the edges. Then we have the main domain entity, the struct telemetry. This is our ubiquitous language word. Everything in RustPulse is about telemetry flowing through the system. Field by field, the design is intentional. Source ID. This is the origin of the data. In the future, it might be an aerospace node or a biomedical device. The domain doesn't hard-code with those type here. It just says some source UUID. Then we have server ID, the collector or gateway that ingested this telemetry. And we have timestamp, when the sample was taken in UTC. Using a real-time types makes logic like latest reading or 20-hour window safe and explicit. Then come the cross-domain metrics, CPU, memory, and temperature. They are wrapped in options because a given telemetry event might not have all of them. For example, a biomedical sensor might expose temperature but not CPU, or the other way around. Optional fields are a very rusty way to model partial data without magic values. And finally, we have the flexible part, extras. This is small but important design choice. Instead of backing every possible aerospace and biomedical field into this struct, we give ourselves a freeform JSON bag for domain-specific metrics. That lets us keep the pipeline stable while we experiment with new telemetry shapes at the edges. From a hexagonal architecture perspective, telemetry is our stable core. The type exists here in the domain. HTTP handlers, repositories, mock generators, they all use telemetry, but they don't get to change it casually. If we had a new storage backend tomorrow, it will be forced to adapt to this domain type, not the other way around. There's also a small helper constructor, empty. It builds telemetry with a current timestamp and all metrics empty. The underscore is a Rust convention for helper that is not a part of the public API yet. You can keep it private while you're still shaping the domain. Later, if it becomes a real invariant enforcing constructor, you might expose it as telemetry new and move more rules in there. Even though this video is just about the domain, it's worth visualizing where telemetry goes next. In the application layer, a telemetry service will expose use cases like ingest telemetry and query telemetry. Those use cases take and return the telemetry domain type. The input ports, traits like telemetry ingest use case or telemetry query use case, live next to the service and also talk in terms of telemetry. On the edges, the adapters convert from external formats into the domain type. The HTTP handler parses an HTTP request and builds a telemetry, and the JSON-L repository loads lines from a file and deserializes them into telemetry. But the direction of dependency is always the same. Everyone depends on the domain. The domain depends on nobody. That's the core of hexagonal architecture. Isolate the problem space here and keep the solution details from rocks, I/O, infrastructure at the perimeter. You might notice there are folders for features, aerospace, and feature biomedical right here. Right now, those files are still experimental and not read into the pipeline yet. So, I'm not going to walk through the code in this episode. The important thing is the ID. Different domains, aerospace nodes, biomedical devices, and so on, will all eventually emit data that flows through the same telemetry core type. Once those features modules are more mature and actually used, we'll come back and look at how they map into this shared telemetry model without violating the hexagonal boundaries. Okay, so now let's wrap up. Hexagonal architecture puts the domain at the center and pushes technology details to the edges. In RustPulse, the domain lives under core domains, and today we focused on the telemetry entity. Telemetry is a pure data structure. No HTTP, no file, no frameworks. Just the business concepts you care about. Stable fields like source ID, server ID, and timestamp form a reliable core, while extras give us room to grow per domain matrix without breaking the pipeline. Every other layer, use cases, ports, adapters, will depend on this type, not the other way around. In the next episode, we'll stay inside the application core and look at the use cases and ports that orchestrate this telemetry domain in a hexagonal way. So, thank you for your time and see you there.